Could be better.
Could be better. Could be better.
Then I'll delete.
Hört man den Sound eigentlich? Yes. I think so. Open your phone, check it.
Oh!
Yeah.
No.
Kann man vielleicht da einstellen?
Here, no sound.
Wo ist eigentlich die Medium?
Because it's connected there. Not here. Nein, Uli.
Don't open sound.
Uli gibt keinen Sound. Gibt keinen Sound.
No, I need this local here.
Okay.
Nice, thank you.
Then will you?
Yeah, we have here.
Jetzt schon.
You touch the sound. He touched the sound.
Leute warten.
Shit, wo ist das Mikrofon?
Oh,
But
this
we
is
need
gonna
the
be
sound for.
Oh, yes.
No, it's working.
Frag vorher, ob jemand Englisch ist. Ja, sagt ja Englisch.
Ja, wegen YouTube, oder?
Ja.
Okay, so good evening. Great to see so many of you. Just a quick reminder, we will do it in English, since maybe there are some of you who don't understand German, or maybe also in the YouTube live stream there is somebody who doesn't understand German. But today we want to tell you what crazy and nice shit you can do with car racing. So first of all, I will present a little bit about car racing, and later each sub-team will present their topics. And afterwards you can still have a power fuel, a Red Bull, or just have a talk in front of the car downstairs at the Ehrenhof. I guess you have to click. Thank you. First of all, yeah, we are car racing and we participate at the Formula Student. But what is the Formula Student? Formula Student is the world's largest student engineering competition. Engineering competition is Konstruktionswettbewerb in German. So this means that in the end, it's not about the fastest lap that you have in the event, but it's about the best overall package. And this overall package also includes, for example, the cost report, the business plan, and the design event. But these events we will explain to you later in the part from the marketing. At the Formula Student in Germany, there are basically two categories. So there are electric autonomous driving cars. And this is also what we are building. We are building an electric autonomously driving car. And the last point, of course, as you see on the picture, this is FSG 2029. It's a big community. Last month we went to Hamburg to an autonomous racing workshop, and there we met people from other teams, and in the end they do exactly the same thing as you, and they're the only ones in Germany who do it. But it's crazy how same it is, because they really do the same thing as you do, and have the same problems and the same opportunities. Now, what is car racing? Well, this is car racing. This is from last year. They were about 80 people, but in the photo, unfortunately, there are only around 50 because it was after the events, and the people after the events were probably a little bit tired. Some quick facts about KA-RaceIng. Yeah, we were founded in 2006 here at the KIT. Now we have more than 800 alumni, and it depends from season to season how many active members we are. It's between 150 from, that we went to events in all over the world, so in Barcelona, Shanghai, Michigan, but normally in a year we participate in Europe, and the events overseas, they are something special for an alumni team. Some big achievements from our side. 2016, we were world champions with the electric car, and last year we basically were world champions for the autonomous car, since we've won everything, but the world list was not updated. Now we can go to the next slide. Yes, and the last topic from my side. For what we are known at the events is our flunkyball rules. Since we have our own beer, we also have our own flunkyball rules, and they are really strict, and you get a lot of Strafbier for everything. So, for example, on the left bottom corner, you can see that in the end, there is nothing allowed to be still inside the bottle. So, no drop of beer at all. And this is our mentioned power fuel. If you haven't had one yet, after the info evening, you can go downstairs and grab one. So let's start with the first sub-team. I guess it's suspension.
Thank you very much. Hello everybody, my name is Uli, and as Thomas already told you, I'm from the suspension team. It's my second year at KA-RaceIng, and I basically want to tell you what crazy shit we do in the suspension team. So next slide, please. Yeah. So the suspension team basically, or the biggest two parts of the suspension team is all the mechanical parts that are part of the suspension. So basically everything that connects the driver with the road and gives them a good feeling for the car and the optimum use of the tire. So everything in the steering for our autonomous car. We also do the steering motor, which is a pretty cool design. Then the spring damper system to make sure that we have the best mechanical grip we can get. The wishbones, the upright that basically holds all the part inside the wheel assembly. Then also for our driver's car, the emergency brake system, which is basically a device where we can hit a button and the car will stand still or brake hard, and also to help us that our driver has a good feeling for the throttle and the brakes. Then also a big part is vehicle dynamics. It's also a pretty interesting and major part of our whole team, because in the vehicle dynamics we basically decide on major decisions we have to do in our overall concept, and therefore we do some analysis for concept decisions, like which tire to use, where we want to have our mass distribution, as you can see in the graph at the bottom, and all these other things. Therefore, we, for example, have a self-developed lap time simulation where we can see what different changes in some parameters like weight, etc. have in our lap times, and thereby decide what we want to do with our whole car. Then also a major part, or a big part, which basically combines the two things, is testing and validation. Therefore, in the summer, we do a lot of testing on our X-Platz, we call it, or it's called. It's basically the Campus OS. yeah, we can see what the changes we made have got in that time and also in the overall performance, and also test with sensors if the changes we want to happened or not, or if we have some made some big errors or failures, because that's always important to see if the changes have bring you any good. Yeah, for testing, we also go on test benches. Here, for example, you can see a test bench at KA. It basically flows the car up and down to see if our dampers are rightly adjusted. And the basic goal is that the tire is always in contact with the platform and that there are no high changes in the force, normal force on the platforms. But we also do pretty straightforward road testing. Yeah, we do some tuning testing, just go with certain steered in and looked what force we get at the steering, and if this also these forces we calculated, then it should be. Yeah, so it's a perfect mix from designing, calculating, but also testing. And I think now we will explain again so we can discuss that. Yeah, and also we do some kind of measurement testing. On the left, you can see some X-rays, because we also have to see if our parts hold up the forces and so on. We calculating them to hold up. And if you skip one more, you can also see a video of the CT scanner from an upright, where we basically see if the 3D printed part has any big holes, and sadly it had. As you can see now on the left, a little steering, and yeah, that's always things we don't want to see, but always quite interesting to see, I think. Yeah, so what we do the whole day, we work a lot with Clio. Maybe some of you don't like it, but it's the most straightforward to use because you all know it. Then we also simulate with other hyperworks, as you can see, for especially in right picture. We simulate with MATLAB, especially in our vehicle dynamics department. And the coolest thing, I think, is you can basically create your own part, see it manufactured, and at the end of the year, you can hold it in your hand and see what you have achieved in the whole year. So that's for me. Now we come to the sub-team that provides some video for us.
Yeah, hi, I'm Robin. I'm currently the sub-team leader of the aerodynamic department. One slide, please, again. Yeah. What we do, we design an aero package for the car. So we have the most flexible downforce you can get, other than in Formula 1. The drag, so German Luftwiderstand, is not important because we drive slower than 100 kilometers an hour on regular basis. So we only care about maximum downforce. So our part of building the car is to build a package that provides the most affordable downforce with having the best balance for the car, so the driver has a really stable and good drivable car. What we do is our sub-team builds the different parts the car needs for this. For example, the rear wing or the front wing, as well as different covers, or as you can see in the picture on the bottom right, the side wing of the car that is included on the monocoque right there. You build your car, your part in Trio, for example, and then we're gonna simulate it and see what effect this part has aerodynamically on the car. And after you see the effects of it, you can change it, simulate it again, change it, simulate it again, till the whole package works well together.
And after we are finished, after a month of development, we will build the car at our workshop out of carbon fiber. And this is all manufactured by hand. And for the CFD part, our CFD Lord is going to explain something to you.
Hello everyone, I'm Akshay and I'm doing the CFD for this season. So, as my dear team lead already mentioned, once anyone has already designed a part in Creo, you have to check it in a virtual wind tunnel, because in aerodynamics, the parts may not work as intended. So it's always good to give all the iterations and put it in a CFD software and check how it's actually performing. So for this, we use this software which is called Star CCM, which is by CFD software by Siemens. So in our simulation, we generally have like two types of simulations. You can run a straight line or a cornering simulation, where you basically, as the name says, you either simulate the car going straight or you have it cornering. For this, we generally use the high performance computers, or we use like supercomputers like Button Multiple Cluster or Horeca Cluster. So on average, like including all the processing of the images and solving, it takes about 6 to 7 hours to solve one simulation. So once everyone's done with their part, I'm basically jobless. But there's other things you can do as the CFD person. So basically, you can write different macros to automate the process as much as you can. So that's really useful, for which we use Java. So yeah, that's part of the CFD.
Thank you. And the last thing, if we're finished our aero package in this season, is to test and validate it. So we have all the simulations done. But the question is, in real life, if the aero package works as intended. So we build aero brakes. You may know them from Formula 1, the testing phases. We built them with different kinds of sensors, as well as building testing wings, having different tests. And with that testing, we're working together with the suspension sub-team to see how the car performs and how we can tweak it to have the best performance as we go through the races.
Hello, I'm David. I'm a member of the current autonomous system team. What we are doing, we are responsible for our driver's car, and we are developing the software for it. On the next slide, what are we using for that? Like I said, we're doing the software development mainly in C++ in the framework ROS, Robot Operating System, but we're also using some other programming language like Python or MATLAB. Actually, if you know them, it's good to work in our team. If you don't, doesn't matter, you can learn them. And on the next slide, you will see our perception. What we are using as the point perception is once the leader on the left, giving us a point cloud to detect the cones. And we also using a camera, or will use a camera to detect the cones, where we use a neural network to do the classification of these cones. On the next slide, you will see a car from above, how our car is building the map, detecting all the cones, and then building the trajectory between those cones. So there's a lot of software developed to develop everything, and we need to make sure that everything is running fine. Yeah. So how does usually the work in the ISAP team looks like? Well, of course, we are coding. We're starting writing the code. Then we are testing our code in a simulation before we then afterwards go to the track and test our car in real life. And for me personally, like that's the best part of the when you can test your code on the real car and let it drift around the corners.
Yeah, then to the electronics, I'm also there. I'm the subteam lead of the electronics. And yeah, right. So the electronics is split into, well, it's not split, but we basically have two major things we work on. The one thing is the software development for our microprocessors, which are the TM4Cs, maybe you know them, they are the ones we use in the electronics, or the electrical engineering workshops at the university, but we also do the hardware design of all of our control units. So none of our control units in the car are bought from the manufacturer. We design them all on our own and program them on our own and use them on our own. So but we also we have the hardware development, the software development, and of course we need to analyze what's happening with our control units, and that's where Campus comes into play. That's the communication bus in our car, used in basically every car in the world. Yeah, and next slide. Then, how does the development process look in the electronics team? First of all, we try to think about ways to improve on our current design. So if it's perfect, nothing is changed. If not, we have to change something. So we start with the schematics. Those are actually pictures from this year. So we start with the schematics, design them in Altium, which is an industrial software or software used in the industry also. And when we have the schematics done, we go to PCB design, or the actual real-life design, how the components will be placed on the circuit boards. And if we have one version of that, we first order them, and then we start writing the code for the new PCB. And if we have the code ready, we can start with testing. So we get the circuit board from the manufacturer, we solder every component onto it, and then we start testing it in our own special E-Stube at the Campus Ost. And if everything works well in the E-Stube and on the table, we try to put it in the car, and that's basically where everything goes wrong, because nobody knows what happens in the car. And then, we have to switch around between table and car and think about ways to get to work. And if you wonder what the pictures are about, the picture in the middle, or the colorful picture, is our circuit board, which is the high voltage battery management system. So this is the board which is inside the accumulator container, and basically makes sure that our battery doesn't go into flames. Then on the next slide, you will see some other products of ours. So on the top left, you see our wiring harness, because we have to connect our control units somehow. Then on the top right, you see basically the switch in the car, which is responsible for turning the car on and off, or the control units for that matter. Then our sensor boards, because we have to know what is going on with the car. So that's why we have sensor boards to look at the sensor data and give them to people like the suspension, because nobody knows what they are doing. And on the bottom right, you see the final masterpiece working. And then on the last slide, I have some quick facts for you. So we have around 30 electrical control units, all designed on our own. And we also use professional equipment, so stuff like Altium Designer is used in the industry, or the software we use to analyze the CAN bus is used in the industry.
And that's the great thing about car racing, because all those firms which produce those software give it to us for free. Yeah, and then I already told you about our control units, stuff like the battery management systems, or the main control unit, which is the brain of the car, and turns it on or off, and tells it how to drive. Yeah, that's for the electronics. I hope I could convince some of you. And the next one is wonderful.
I'm Felipe. I'm in the second year of car racing, and I'm the sub-team lead of the chassis or the monocoque sub-team, which is responsible for the biggest part of the car, the monocoque, and all the other structural parts of the car, which means the rims and the seat and so on. Yeah, now the next slide. So here you can see the CAD model of the chassis from last year. Basically, the huge carbon fiber part is included in the chassis sub-team. You have the rims, which are made out of carbon fiber, the ergonomics, so the seat and the steering wheel, like you have to design those as well, so the driver is comfortable, or as comfortable as possible. And then you also have the crash box in front, because that's mandated by the regulations. You have to make some crash tests for that to demonstrate that it actually works as well, because that's actually important that the driver doesn't die in a crash if you do. And then, of course, all the carbon fiber parts have to be simulated beforehand, because we don't have that much money to build 1,000 prototypes to test them. Yeah, so that's all the most important parts that are included in the monocoque sub-teams. So the general process of the monocoque is you do some pre-development at the end of a season or at the beginning, test out what kind of configuration we want in the car, where's the battery, how does the battery look, where does the driver sit, how does he sit, is he more upright, is he more reclined, and so on. Then you develop some concepts in CAD, see what works, what doesn't, try to realize your ideas, and then you design more, do some Creo work, or try to get to work with Creo, which never really works as the way you want. Yeah, that's an image of the current model in CAD that I designed for the mono. Yeah. After the design, you move to the manufacturing. So you start laying some carbon fiber. You can see the monocoque from the inside, or on the right side, you see the first layer of the carbon fibers, where you start to try to lay the carbon fiber as cleanly as possible. So you get an accurate representation of the simulation and the real world, so you can compare those two. Yeah, you try to lay the carbon fiber, and then after that, you have the rolling chassis where the mono is completed, and you can move on to manufacture all the other parts. Yeah, that's the general design process. Then there's of course the simulation, because the chassis gets huge loads from all the wishbones and so on are transmitted into the car. So the chassis has to be simulated that it can withstand those forces, which is a very long process, all done in Altair HyperWorks as well. We use that not only for the FEM simulation of the suspension parts, but also of the carbon fiber parts, which is a very long, but also very interesting process that is very complicated, but you can learn a lot from that. And that basically uses all the loads we get from the different parts in the car, and then tries to kind of make a light car that still is very stiff for the suspension, because if the chassis moves or twists in a way under load, that's not ideal for the suspension, because then behaves in ways you don't want to. So we have to make sure that the chassis is stiff and doesn't move. But if we make it stiff and immovable, it also gets heavy, which is also not good. So we have to find a compromise and make it as light but also as stiff as possible, which is what we mainly use the simulation for, which we then try to apply to the manufacturing. So if we move on, there's also some other parts. For example, again, the mock-up for the ergonomics, so we can test how does the driver sit. Is it comfortable to sit that way? Where do we put the steering wheel? Is it not too far away, and so on? Which is always difficult to guess. Like if you're looking at a picture of a CAD model, like is that comfortable to sit in? I don't know. If the steering wheel is too far away and you only notice when you're manufacturing the car, there's not much you can do, but that's what mock-ups like this are for. Then you obviously do some simulations on the carbon fiber rim to make sure that it doesn't break like last year. That's a funny story for later. Then you do some crash tests. That's a video you can play, maybe. Yeah, that's a video where you basically test it and look at the results, and then you can see if the driver dies or not, or at least gets injured. Yeah, and then on the lower left, you can see the current picture of the current chassis that we are working on. So this is from yesterday, I think, which is basically where we are manufacturing a mold for the chassis out of carbon fiber as well. So also not only do you do simulations and designing in CAD, but you also work with carbon fiber. Yeah, I don't remember that slide, but next. Right. Yeah, that's it from my side. Now we have the powertrain.
Yeah, so hey, I'm Vincent. I'm from the powertrain. And yeah, next slide, please. Thank you. Yeah, what parts are in the powertrain? Firstly, we have the battery. Then they give like juice power to the inverter and power electronics. They distribute the power to the electric motors. And yeah, the last part in this chain is the gearbox, which then gives the power to the wheels and to the tarmac. So yeah, the powertrain is vital for the car to drive, because if the battery is not juiced up, there's no drive. Next slide, please. So yeah, here, some hard facts, quick facts. The battery, we have a peak voltage of 600 volts, energy of 7.3 kilowatt hours, and with the weight of 52 kilograms, the battery is the biggest part and the heaviest part in this car. And then we have a picture of the gearbox. One gearbox, can give the wheel a maximum torque of 300 Newton meters. We have 4 of those in the vehicle. One weighs at 2.1 kilograms, and the efficiency is at 97.2%. So that's already pretty good, but we want to do better. That's why we need you. Next slide, please. Yeah, how do we develop the powertrain? So this is basically the same in all sub-team. We have the different phases in the year at KA-RaceIng. So first of all, we have the concept phase, where we decide what we want to change and do better, or leave it as it is. And yeah, after that, we go into the design phase, and that's where the actual construction is done. And yeah, we mainly work in CAD, but we also have other software tools, as you can see at the top there. After the construction, we also have to validate via simulation that the things we build in CAD aren't crap. And yeah, we are also very proud that we basically built every part of the powertrain, and every part is self-developed. So we also manufacture the motors, the power electronics, the battery. Basically every part in the car from the powertrain is self-developed, as for the other sub-teams, the other parts. But especially for the motors, we are very proud of. Yeah, after the designing, what do we do? Yeah, we build all the parts, as I said, ourselves. So on the top left, you see a picture of the manufacturing of the PCBs for the power electronics. And the second picture is from the manufacturing of the batteries. And the next pictures are from the motor, gearbox, and cooling system. So yeah, basically every part is built by ourselves, as I said before, or are manufactured from by sponsors of us. Yeah, after the manufacturing, testing, and events, this is where the fun begins. So yeah, we evaluate the telemetry, look for errors, things to improve. Is the car behaving as we want it to? And yeah, with those information, we can pre-develop for basically every part and for the next years through the testing. So that's quite cool. Yeah. Now to the finance.
Exactly. Yeah. Hello, I'm Paul. I'm the current CFO, so the finance guy from KA-RaceIng. The finance is the most important position in the team, because without the money, nothing will work. Yeah. But handling the finance is obviously not the only thing you have to do. As the finance guy, if you want to become that, you will be part of, or you will be a board member, so you will be involved in all major decisions regarding the team and all the sponsorship decisions. And obviously you will have to manage all the money the team has and gets from the sponsors and other supporters, which is obviously, well, part of that is obviously the budget planning, the monitoring, so you have to keep watch out for all the sub-teams that want to spend all the cash without leaving any to the other sub-teams, and also the accounting, which is basically the stuff you need for the government, so they don't get on your nerves. Yeah, but it's also possible to get involved with a technical sub-team. So you don't only have to do finances. Most of the finance guys in the past, and me as well, were involved in a technical part in some time. So we hope to get some of you to become a finance guy. Yeah, so over to the marketing.
Thank you. Hi, I'm Farabi. I'm this year's marketing sub-team leader. Yeah, one obvious thing about the marketing is, of course, we manage our social media channels. For example, Instagram, we post most stuff there. But we also have a Facebook and YouTube channel and everything. You probably already saw it if you Googled us once. And yeah, we also take care of our website and write monthly newsletters to our sponsors, so they keep giving us money so we can build a nice car. But how do we get those nice shots for our social media channels? Well, we also have a photo and film guy who basically captures our journey in the team, milestones, or takes pictures for a nice calendar. Yeah, but we also film some cool videos for our sponsors. For example, when they give us a product, some of them at least, they want a short video of us using it so they can upload it on their social media. So yeah, we also film that. And one very, very important task is the rollout videos, obviously, because yeah, who doesn't like a good video at a big event? Yeah, talking about events, well, we have a lot of events on campus. For example, tomorrow we'll be at the Mensa, but one very important one is our rollout. It's the biggest event of the year, and usually we expect more than 800 visitors. Yeah, so if you want to come, it's on the 18th of May at 6 p.m. Here at the Audimax. So yeah, feel free to join us, see our new car, yeah, and just hang out with the team. Yeah. I just talked about calendars before at the photo and film part. Of course, those calendars have to be designed, and that for we have also a design person. Yeah, that person's job is to come up with cool designs for our merchandise, like this polo or yeah, basically all the merch our team is wearing today. It's not much yet, but of course designing merch is not that exciting, but seeing your design on the car is exciting, and that's also what the design person does. Yeah, and next slide, thanks. We also take part at the events. We have two major events in the events. As Thomas said in the beginning, we have the business plan and the cost report. In the business plan, it's quite exciting because you get to have an own idea, and then you can pitch it in front of potential investors, and hopefully they will tell you your idea is great, and if not, so be it. For you, it's still great. But part of that is, for example, filming a nice pitch video, so you get accepted to pitch it, or making fun designs. It's basically building a whole organization from the ground up, just to impress some people. Another part of the events is, of course, the cost report. There you can meet the whole team, because you need to put together a detailed list of all the components and their cost, and then at the event you can explain why you spent what you spent on, for example, some screws. So but it's pretty interesting because you get to assemble data from the whole team. So you meet every sub team, you talk with them in depth, you know what they spent, why they spent it, so you get a technical knowledge of the car. And then you have to put together a detailed spreadsheet for the judges, because they will ask you to go into detail. That's why I just had the example of screws, because who talks about screws? And then they will ask you questions about it, and then you can show all your knowledge about why you spent what you spent and get a good result for the team. And then back to Thomas.
Great. Now we are done with the presentations from the sub-teams. But before we go downstairs, I just wanted to show you some more slides and tell you something that is personally to me really important. If you have seen now all these simulations, models, and pictures, and you think, oh my god, it looks so complicated, and I have never coded before, and I don't know how to use MATLAB. This doesn't matter. You do not need to bring the skills. The only thing you need is to bring the motivation to learn it in 1 year. So it doesn't matter. Also, for each sub-team, it's the same. You just need to be motivated for the year. And to show you this, the KA-RaceIng is not always complicated models and equations. I have some pictures for you from your time at KA-RaceIng. First of all, you will spend some time at the campus, and there we also have a little kitchen, and we at least try to cook some food. So on the left, you see Jonas, who's eating a really, really big piece of pizza. In the middle, a really crunchy baguette. And on the right, I guess it's a toast with a heat gun. Then after the food, yes, you will spend some time in the team, and you will get tired, but what you learn in KA-RaceIng is you can see it everywhere, on the floor, in the workshop, again on the floor. And the last one, the events in the summer. This is the highlight for everybody. You work a year together, and in the end you can present what you have achieved as a team, and in the best case you win this competition. And on the events, it's just a big community, robot teams, we spend a lot of time together. And now, yes. Again.
Hold me like you want to. Tell me what you're into. Let me take you back to old school. Baby, let me show you. It's a
Now this slide works. These are our next events. So next Wednesday, Wednesday in 2 weeks, the 18th, our rollout in the evening in the Audi Max. On the 24th of May, the open door day from 4 p.m. on at the Campus East. Application deadline is 15th of June. In June, there will also be a get to know weekend, and August, the season will start. But the dates, you can look them up on Instagram. And now we talked enough. Now it's your part. Do you have any questions? No questions? Yes. Egal.
Inwieweit habt ihr Vorgaben von Regularien, was ihr einhalten müsst, und Vorgaben Einheitsauto, wo ihr dann abgenommen bekommt, oder das ist eigentlich ziemlich frei?
Also an sich ist es, also die Frage war, wie spezifisch die Regularien sind, ob es Einheitsautos gibt oder wie frei man da gestalten kann. Also an sich ist es ziemlich frei. Also es gibt ein Reglement, das ist 100 Seiten lang. Das klingt jetzt sehr lang, aber an sich gibt es halt viel Freiheit. Es gibt ein paar Sicherheitsregeln wie HV-Zeug und Chassis muss aushalten, wenn es nicht kommt. Aber an sich Aerodynamik oder so, das ist komplett Freiheit. Es gibt kein Standardauto, es gibt auch eigentlich keine Standardkomponenten. Also es gibt so eine Crashbox, die standardmäßig kann, aber du kannst zu jedem eigentlich deine eigene Lösung bringen, solange du weißt, dass sie äquivalent ist. Und dann hast du eigentlich alle Freiheiten. Und ich glaube, wir haben auch so ziemlich alle Freiheiten ausgenutzt, also fast alles ist selbstentwickelt, wie ihr gesehen habt. Also man kann alles machen. Das Einzige, was aktuell noch nicht selbstentwickelt ist, sind, glaube ich, die Reifen und Batteriezellen an sich. Das muss man aber auch nicht machen. Aber es gibt Teams, die machen das auch. Das ist eigentlich alle Möglichkeiten. Ja, und solange du Lust hast, es selbst zu entwickeln, kannst du es auch machen und dann darfst du es auch machen. Es gab Leute, die sagen, ich möchte meine eigene Leistungselektronik entwickeln. Oder die haben sich das vorgenommen. Und dann haben wir das auch gemacht. Also geht. Solange du solche Lust hast. Wünschenswert, bis die Regel kommt. Ja. Genau. Another question? Oder gibt es noch weitere Fragen?
So, which type of algorithm are you using by machine learning? So it is monoliths or functions algorithm?
I didn't understand. I only understood something. So can you just repeat your question?
So there's lots of types of machine learning algorithms. So the default structure for algorithm is monoliths or it is microfunctions algorithm.
Look at this classical.
So yeah, the different models for machine learning are defined on the problem. For example, we use some reinforced learning for the velocity estimation. This was a masterthesis of one of our alumni. Currently, it's not in the car because we have a better solution. But for example, if you want to do the object detection with cameras, you basically can build up your own system. The old one is probably not working anymore, and it's not precise enough. So there you have the full freedom. This was, I think, this was built up last season with TensorFlow and so a normal neural network. For object detection, I think YOLO say you something. YOLO is a specified machine learning algorithm for object detection in images. So that's used, for example, for the code detection. Yeah, so we have any kinds of machine learning algorithms that we can use. but I think currently is no machine learning inside of the car. Yeah. So maybe a challenge to get machine learning into our car.
Big machine learning algorithm for sellers or big data algorithms. Then you can combine them to small monolithic algorithms that's been used in our which all these data for you eliminate each word with the operation will are directly in time.
So one thing is our programs are really separate. We have a really modular structure of our code, so we have different parts. So I don't think one algorithm for every. We have different problems you have to consider and you have to solve. So one thing is, the first one is the perception. So you have to detect your environment and you have something which is your vehicle control, and these problems are so different that we have modular solutions, so everyone can work with it. One item for
I think currently there would no solution exist for one big data algorithm. I think it's not even possible in the current state of technology, because you have, for example, the control, and the control, for example, is a model you can put really hard into such machine learning stuff. But there he can tell you a little bit more.
Yeah, and on different topics or problems we don't want machine learning because it's fast but complicated. So it's not deterministic, it depends on the data, the training, and even you have lots of training and the tests were successful. Basic machine learning approaches, you can predict what happens if there's an unknown situation. If you have something like that, so you know, okay, if I have these codes, the result will be that I know, okay, this would be not good or something else, but you know, every time I get this input, output, and therefore machine learning is not all the way and not all the way everywhere.
Zero shots on use that can be used in such applications.
I get the node later. Another question. Or I think this detailed question can be
Let's go to the cars.
That could be klein.
Okay.
Okay. Did it work?
Not exactly perfect.